Section 6.2 is titled Multiplying Polynomials. We'll look at how we multiply all types of polynomials, and then we'll look at a special case of how we expand binomials raised to powers, and we'll use kind of a trick in Pascal's Triangle to help us do that quicker. First type of problem we'll look at is how do we multiply a monomial and a polynomial together. And this is really not necessarily new information. We've done this sort of thing before. We're going to use distributive property. The key is to remember that when we distribute and we multiply variables together, we're going to add the exponents above those variables. So when I do 4x squared times x squared, it is 4x to the fourth. Power becoming 4 because we're doing 2 plus 2. When I distribute it to the 3, I'm just doing the 4 times the 3 to make 12, and that x to the second just kind of comes along for the ride. That's our answer to the first one. The next one, we're distributing mn, and those are both first power mn into all this polynomial. So it's going to go here, here, and that one, and that one. And we're going to add exponents as we do this. Remember, the exponents on the m and the n up here in front are both ones. Okay? So mn times n to the fourth is m to the fifth n. The next one, mn times 2m cubed n is 2m to the fourth n to the second. This exponent is also 1, so it's doing a 1 and a 1 combined to make the 2. Minus, I'm going to have 3m cubed n cubed plus, and then I'll have m squared n to the fourth. And that's finished. Next, we're going to multiply two polynomials together. It's basically like a FOIL problem, but a big FOIL problem. I'm going to begin with the a. The first term here needs to distribute to all three of these terms. So a times 2 is 2a. A times negative 5a is negative 5a squared. A times a squared is a cubed. Now I want to distribute negative 3 as well. Negative 3 times 2 is negative 6. Negative 3 times negative 5a is plus 15a. And negative 3 times a squared is negative 3a squared. Okay, now combining like terms, the a to the third is the only one of those. I have a squareds here, and they combine to give me negative 8a squared. I have a's, which combine to give me 17a. And then this minus 6 is the only constant term, so minus 6 at the end. Alright, the next one, it's again just a even bigger multiplication problem. I begin with x squared distributing to all three of these. X squared times x squared is x to the fourth. X squared times negative x is negative x to the third. And x squared times negative 3 is negative 3x squared. Okay, next I'm going to distribute this negative 7x. It's going to go to all three of these. So negative 7x to the third plus 7x squared plus 21x. Then finally this 5 is going to distribute. So plus 5x squared minus 5x minus 15. Okay, now like terms, the x to the fourth is the only x to the fourth. Next, x to the thirds. I have two of them. They are negative 8 x to the third. Next, I want x squareds. There are three of those. So negative 3 plus 7 plus 5 is going to give positive 9 x squared. Then I want x's. 21 minus 5 is 16x, and then the minus 15 is the only constant term. Alright, here's a couple of problems for you to try on your own. See if you can do these before moving on in the notes. Again, if you want to pause, try them on your own, then push play and watch the playback after you've worked the problems, that would be outstanding. Begin by distributing negative 9x, gives me negative 9x to the third minus 18x squared minus 36x. That one is finished. The next problem, I'm going to distribute 2x squared to both of these, so that's 2x squared y squared plus 6x to the third. And then I will distribute the xy to both of these, so that's going to give me xy to the third plus 3x squared y. And then we'll distribute the negative y to each of these. Negative y to the third minus 3x y. And then we look and see if there are any like terms at all. And I think scanning over this entire list of terms, there are none that are identical. So this is finished as it is. Next thing I want to talk about is how do you expand a binomial. So here the problem is x plus 2y quantity cubed. That's the same as x plus 2y times x plus 2y times x plus 2y. Okay? Now when we multiply these together, we can only do 2 at a time. Okay, so let's just ignore the one in back and let's do the first 2 multiplied together. Okay. So if you like, draw the lines if it helps. I'm going to do these products and this product. So we get x squared plus 2xy plus another 2xy plus 4y squared. We have some like terms right here, giving me x squared plus 4xy plus 4y squared. And we still have this extra x plus 2y to do. Okay. Well, now we're going to multiply again. Okay, so that means the x squared goes to each of these. The 4xy goes to each of these. This 4y squared goes. So we're going to run through all 6 of those products and then simplify like terms again. We get x to the third plus 2x squared y plus 4x squared y plus 8xy squared plus 4xy squared plus 8y cubed. I have some like terms here, and I have some like terms here. So combining those, we get x to the third plus 6x squared y plus 12xy squared plus 8y cubed. Okay, so that was x plus 2y cubed. It's a lot of work, but it wasn't completely unbearable. It was doable to do that problem. The question becomes though, well gosh, well, I know how we do it, we just do it again, but you know, what if this power what if this was 5? Okay, or 6 or 7. You know, you have to take this 4 terms times another x plus 2y, and that gets you the 4th power. And then that answer times another x plus 2y will get you a 5th power. You can see how every time I do another x plus 2y, it just becomes more and more terms, more and more products, more and more likely that maybe I'm going to make a mistake. And just really, it just takes more and more time. Well, what we're going to do next is teach you a shortcut to expanding binomials, one that will make pretty much every one of these problems, regardless of what the power is here, a 1 or a 2-step problem. Maximum 2 steps. Possibly even a 1-step problem once you get the hang of it really well, and if you're pretty good on the mental math, potentially. But all this we won't have to worry about anymore. Well, to get to that shortcut, we need something that's called Pascal's Triangle. Pascal's Triangle, presented right here, offers us loads and loads of different patterns. We could spend an entire class period in school probably looking for patterns and investigating patterns and that sort of thing. And I'll point out a couple, maybe just how to build it at least. Begin with 2 rows of diagonals, or you just go with a 1 and then the next row is a 1, 1. The third row across, all the rows always start with 1, always end with 1. And then the other numbers, I get the 2 by adding the 2 numbers directly above it. 1 plus 1 make 2. Next row, we start with a 1, and then the next number, we add the 2 numbers above it. Next one, we add the 2 numbers above, end with 1. Okay, next row leads with 1. We add the 2 numbers above, get 4. Add the 2 numbers above, get 6. Add the 2 numbers above, get 4. End with a 1. And we can keep building rows like that. Okay. Now, Pascal's Triangle, what it gives us, what we need it to give us for what we're doing, this binomial expansion, is it gives us the coefficients of the terms of any binomial expansion. Okay, pretty convenient for us, to be honest. All right, so the coefficients are this. The first row is used for x plus y to the 0. The next row is used for x plus y to the first. Next row is used for x plus y to the second. Next row is for x plus y to the third. Next row is for x plus y to the fourth, and so on and so forth. Now, it's not a triangle we need to memorize, really. If I memorize the first 2 rows, this triangle of 3s, then I can just build on out to any row that I need. And that's not going to be hard to do. So let's show, I think I've got 3 problems here that are going to show kind of step by step how we're going to do this, how we're going to use this triangle and these numbers in the triangle to expand binomials. Alright, the problem says x plus y to the 4th. 4th power, look at the 4th powered row and you find the numbers 1, 4, 6, 4, and 1. Okay, those are the numbers that we're going to use. Now, here's how we do it. Let me write the whole thing out first, and then I'll talk you through the pattern of how I'm writing it out after I do it. All right, there it is. Now you do no doubt see the 1, 4, 6, 4, 1. Okay, those are the coefficients coming from the row in Pascal's triangle. What you might also discover as I set this up is that the powers of x go down by 1. Powers of y go up by 1. And one other thing, powers always add to 4. Okay. Now the powers add to 4 because this is x plus y to the 4th. Whatever power is up here is what the powers of all the terms would add up to. In this case it just happens to be 4. But essentially we start with 4 and 0, and then the x goes down 1, y goes up 1. X goes down 1, y goes up 1. X is down 1, y is up. X is down, y is up. Just like that. Now I do simplify this from here. The first term is simply just x to the 4th. Of course the y to the 0 is just 1, so we just get rid of it. The next term I write as 4x to the 3rd y. Next term is 6x squared y squared. Next term is 4x y to the 3rd. Last term is y to the 4th. So when I simplify to get my final answer down here, what I like to do is just, I drop the coefficients of 1s, of course. I drop off the 0 powers, and then these x and y's to the first power, I just drop off the 1 as the exponent, because of course we don't need to write the 1 as the exponent, just to kind of clean it up. But there's our final answer. Really, that took 2 steps. And once I get the hang of it, I could get here in just 1 step. And you can too once you practice. Next one is x plus 3 to the 3rd. It's a 3rd power, so I'm going to use 3rd power row, which is 1, 3, 3, 1. And so again, let me set it up here. I've got 1 x to the 3rd times 3 to the 0. The 3 takes the place of the y, because before it was y, but it's just whatever's sitting here gets that power. Next is 3x squared, 3 to the 1st. Next is 3x, 3 to the 2nd. Next is 1x to the 0, 3 to the 3rd. Okay, so you see the 1, 3, 3, 1 at the front of every term. See the powers of x go down by 1. Powers of 3 go up by 1. Okay. Now we're just going to simplify here. The 3 to the 0 can go away. The x to the 0 can go away. First term is just x to the 3rd. Next term, I have got a 3, but I need to multiply it by this 3 to the 1st. This is 3 times 3, so the next term is 9x squared. In the next term I've got a 3, but I need to multiply it by 3 squared. So that's going to be 9 times 3, which is 27x. Last term I just have this 3 cubed, which is 27. That's it. Alright, I want to give you one more, as I want to give you one that's about as hard as we can make it, as it's got coefficients in front of both the x and the y, and it's even got a minus sign in there too. So this is really about as hard as they can come, I suppose. It's a 4th power, so it means I'm going to use 1, 4, 6, 4, 1 as my coefficients. So let's see, the first term, I'm going to start all the way to the left here because this is going to be pretty long. I've got 1, 2x goes to the 4th, negative 5y to the 0. Plus, next is 4, the 2x goes down a power, negative 5y goes up a power. Next is 6, 2x goes down a power, negative 5y goes up a power. Next is 4, 2x continuing to go down a power, negative 5y goes up a power, finally 1, 2x goes down a power, negative 5y goes up a power. Alright, so now we need to start simplifying all these terms. And so let's begin by just removing the stuff that we can remove, I suppose, that we can just ignore. The negative 5y to the 0 can get ignored. This 2x to the 0 can be ignored. So can the 1's in front. So can these first powers. We can ignore those. Alright, now we just have to start simplifying from here. And I might have to show this in 2 steps, quite possibly, as some of the computational math will be difficult. I've got 2x to the 4th. So 2 to the 4th, 16x to the 4th. Next term, let's go ahead and do this in 2 steps. We got 4 times 2x cubed is going to be 8x cubed times negative 5y. Next we have 6, the 2x squared is 4x squared. The negative 5y squared is 25y squared. Next we have 4 times 2x times negative 5y cubed is negative 125y cubed. Plus, then we have just the negative 5y to the 4th is 625y to the 4th. Okay, so now comes the products. Within each of these terms in the middle, I've got to multiply those numbers together. Let's see if we can do that, and feel free to use a calculator if you want. There's no harm in doing that. 16x to the 4th times, looks like we're going to have, actually it's going to be minus, because there's a negative sign right there. We're going to have 160 x to the 3rd y. Next we're going to have plus 600 x squared y squared. Next we're going to have minus, and let's see, this is going to be 1000 xy cubed, and then the 625 y to the 4th at the end. Now with practice, you could do this and get it all the way to here in 1 step. I could do it, it'd be a little challenging, it might hurt a little bit because you gotta keep track of all these numbers and numbers to powers and multiply them all together, which is why I recommend writing out the whole thing here first, and then if you can, you can go from this to here. But I wanted you to make sure you saw all the intermediate computations going on too.